Hi, in this video I'm going to be going through worked example 4 today. So at the end of each year, $1,000 is invested at 5.75% compounded annually. So the first thing we have to do is we have to set up a recurrence relation that represents the value of the annuity after each payment is made. So the first thing I'm going to do is I'm going to write my recurrence relation out. So that's a n plus 1 equals r multiplied by a to the n plus d comma a0 equals a. Okay, so that is our recurrence relation that we are working with today. Okay, the second part is to identify all of the variables. All right, so the first thing I'm going to identify is my r value. Now to find r, it is 1 plus x over 100. X is the compound interest rate per payment period. So my x is going to be 5.75%. Okay, and we're going to divide that by 100. All right, so my r value is 1.0575. Our next value that we are identifying is D, which is the payment amount. The payment amount is $1,000. Okay, and then the last one we're identifying is the initial amount, which is also $1,000. Okay, now that we've worked out all the variables that we need, okay, we can now sub all of that into our recurrence relation. And this will be the answer for part A. So R is 1.0575 multiplied by a to the n plus 1,000, which is D, comma, A0 equals 1,000. Okay, so that's our recurrence relation for A. Okay, we need this recurrence relation in order to do B. So that's really important. Okay, now B says, using the recurrence relation from part A, can you please find the value of the annuity for the first 4 years? Okay, so if we are finding the value of the annuity for the first 4 years, that means that our first n value is going to go from 1, 2, and 3. They're going to be our 3 n values. Okay, because you need to keep in mind that when you're working out the interest in an annuity, okay, that is going to be compounded at the end of each payment period. Okay, so you won't get the payment until the end of that period. All right, so let's do the first one. So after the first year, we're going to go n equals 1. We're going to use our recurrence relation to work this out. So 1.0575, multiply that. This is what a to the n is going to be. A to the n is our initial value. So our initial value as of now is $1,000. Okay, and then we're going to plus our D value, which is 1,000. So our first value is going to be $2,057.50. Okay, we're going to do the same thing again, but we're going to do n equals 2. Okay, so the same thing still applies. We use 1.0575, multiply that by a to the n. A to the n is our previous value. Our previous value is 2,057.5, and then plus the 1,000. Okay, our second amount is 3,175.81. And then our final is when n equals 3. Okay, so we're going to do 1.0575, multiply that by our previous value, which is 3,175.81 plus 1,000. Okay, and that's going to give me $4,358.42. So you just have to sum it up with just a statement. So the values of the annuity for the first 4 years are 1,000. That's what we start with. Our next one is 2,057. Sorry, let's get rid of that. $57.50. Our third is 3,175.81, and then our last one is 4,358.42.